scenario, two dogs are pulling their owner as in the diagram. Determine the minimum magnitudes in pounds of each vector to keep the owner from being pulled. What's happening here is the dogs are both pulling in the opposite direction of the owner, and no one is moving. We have to think about everyone being gridlocked. No one's moving, everyone's pulling with all their might, and the dogs aren't moving and the owner's not moving. So when we look at this problem, we need to recall the formulas for components of a vector. You take the magnitude times the cosine of your angle. That's the x component, and then the magnitude of the vector times the sine of the angle. So we need to find the components of each of the three vectors in the diagram. So we've got dog 1. I'm going to give this a name, vector R. Dog 2, I'm going to call vector S. And then the dog walker. We can call him vector W. Each of these vectors can be written in terms of their components using the formula we just wrote down. So for dog R, the components of his vector are going to be magnitude of R times the cosine of 30, magnitude of R times the sine of 30. That corresponds to his horizontal component going left and his vertical component going up. Now I want you to think about something because we're actually missing a piece of this. If this is a coordinate plane, if this dog walker, if I assign an x and a y axis here, then these dogs are opposing the dog walker in the negative direction. So this horizontal component of the vector should actually be negative because it's going in the negative direction. From there, the dog does go up, which is vertical, and positive in the vertical direction. So that's why the vertical component remains positive. Now let's think about dog 2 and his components. So we take the magnitude of S times the cosine of the angle 45, and then the magnitude of S times the sine of the angle. Once again, we need to think about the direction in which this dog is walking. So for this dog, he's also moving left. Sorry, not that far. And then he goes down. So for this dog, his vertical component is negative, his horizontal component is negative. Both the horizontal and the vertical component are negative. That's going to be really important when we set up our equilibrium formulas. The dog walker is much easier to calculate his components because it's all in the horizontal direction, the positive horizontal direction. He is pulling this way with a 180-pound force, so his components are going to be 180 and 0. Now that we have these components for these three vectors, we need to think about what it means to achieve equilibrium. That means the sum of the forces in the x direction are equal to 0, and the sum of the forces in the y direction are equal to 0. So I have to look at all the forces in the x direction, add them up, and it needs to be equal to 0. So for the dog walker, his force is 180. Dog R, his horizontal force is a negative magnitude of R cosine of 30. And dog S, his horizontal component is a negative magnitude of S cosine of 45. Now let's look at their vertical components. The dog walker has 0 vertical component. Dog R is the magnitude of R times the sine of 30. Dog S is a negative magnitude of S, sine of 45. These forces are all going to add up to 0 in the x direction, 0 in the y direction. Now, one of the biggest problems we're encountering is that we have two variables. I need to know the magnitude of dog R, and I need to know the magnitude of dog S. I have two equations. I have two variables. I'm going to have to set up a system of equations. So I'm going to rewrite this first equation with the constant by itself. So I'm actually going to add these two terms to the left side. So I'm going to add the magnitude of R cosine 30. I'm going to add the magnitude of S cosine 45 to rewrite it as R cosine 30 plus magnitude of S cosine 45 equals 180. Now I can use these two equations and set up my system for a matrix. In a matrix, an augmented matrix, I leave out the variables. So I'm going to have cosine 30, sine 30. Remember, this pertains to magnitude of R. And then I use this cosine of 45, negative sine of 45. Do not forget we have a negative there. This column refers to vector S, or magnitude of S, and then our constants, 180 and 0. If I plug this into my calculator, I am going to need to use my calculator to do reduced row echelon form. This is only one option for solving a system of equations. You could have algebraically solved this, especially because you should know what the cosine of 30, sine of 30, cosine of 45, and the sine of 45 are. But when I use my calculator, I get a reduced row echelon form matrix that looks like this: 1, 0, 0, 1, 131.77, 93.17. What this is telling me is the magnitude of dog R. The force of dog R is 131.77 pounds, and the force of dog 2, dog S, is 93.17 pounds. And that is a final answer for this problem.